Right, day two in the house. Well, it's only day two because it took me all day yesterday to tidy this place up and set up at studio. So, what I want to do is get a quick start on this and sort of do a simple installation, and let's see where that takes us. In true Blue Peter style, here's one I made yesterday evening. It literally is as simple as it possibly can be. Basically, you're in that's left, that's right, and that would be stop start. So literally that's all it does, and it uses this little Arduino as its output, and that's what it's doing. So you can actually hear it doing. I don't know what K does on the Windows, but apparently it has a function. That gives us a sort of basic start. Oh, and we've got another one. So that basically is a running solution, and I'll try my best and as quick as possible to show you how I did that, and we'll see what the feedback is as to how simple it is. Anybody that has a go. So. That's interesting. We seem to have got a bling now into everything I do. Don't know why, but anyway, so that's probably what you get for pressing a K on the thing. I wonder if there's something. I wonder what K does in Windows. You learn it every day's a school day. So that's our little joystick, and it's got 5 pins coming out of it. And what we're going to do is we're going to take that end pin, which is ground, and connect that into the ground. Now you've got to connect it to the ground on this side. I don't know why. If you get to this side, it seems to have issues. I'll find out what that is later, but this is the first time I've worked with this little micro board, and you learn as you go. Then we're going to take the plus volts and connect that into the 5 volt there. That's actually 5 volt there. That's why the arrow's there to tell us that's 5 volts coming out. So that we've got 5 volts. So we've now got power at that stage going to the actual button. Then the next 2 are the variable signal that comes with the with the actual joystick, the way the joystick goes left and right. Now then, they need to go to analog channels. Now these are your analog channels, A0, A1, A2, and they will measure a variation in voltage. So we'll take one of those, and it doesn't matter which one you take. You can swap them later if you don't like which horizontal or vertical, or you can do it in software. And then the final one is the switch, where when you press down the button, and that we're going to take over to pin 12. So 5 wires is all we need, and that will get us connected. Then literally that will be the basis of how we're going to run it, and then we need to write the software for it. So if I pop one of these out of its box, and they come with a nice little set of stickers if you're really that bothered, and they just come on a bit of foam. The foam's there, one, to stop the pins getting bent. It is an anti-static foam, but in reality, as long as you've not got a lot of static about, they're fairly safe devices. And then we need a joystick. So what I'm going to do now is I'm going to use things called DuPont cables. Now those are DuPont cables. I'm just going to disconnect this because I think it's causing issues. If I disconnect the thing, then hopefully it won't cause problems with the recorder, but we'll find out. So we're now going to relate what we've done on this drawing to what we're actually going, the way this goes together. So only for convention, I'm going to get myself take myself a red wire out and a black wire out for my power. The orange has fallen off, that'll do, and I'll take a green and a yellow. So I've now got 5 wires pulled out, and you can just read on here if you can get close enough. It's not close enough on that camera, but you can read on the little, what's called a print, the silk screen. It's telling us, pull that pin a little bit, it's just that is ground, so we put the black one in there. Now these are called DuPont cables if you want to buy them. They come in packs of males to males, females to males, and males to females to females. That's as plus volts for the power, and then I'm going to use either yellow or green for the two. Sometimes they're a pain to put on, sometimes they go straight on. That's on. Get the yellow on, and then the orange. Like I say, electricity don't care about the colour of the wire, and we're only talking 5 volts. It's tiny bits of electricity. So now we need to identify this board with the sheet that we've got. If I can separate it, sorry about that. So that's the sheet we've got. It normally is orientated so that the port is at the top. So the first one I need is the ground, which is 1, 2, 3, 4, 5, 6 pins up. It is actually printed on, but sometimes it's easy to go 1, 2, 3, 4, 5, 6 pins. So there is actually a nice big white splodge on there to tell you that is the ground, and we've got 5 pins. I'm going to cheat and go straight away to the orange, which we know goes to the 12 on that far end. No point fighting it, and the less light wires you've got, the better. And if you notice, like a plank, I've taken the red wire and put it onto the black. Want to be in the end of the world. It's amazing how much these things will survive. So let's try it with a black wire on the actual ground. It's amazing what mistakes you make, and that's one of the nice things about using things that power off USB. You make mistakes, and and you don't really end up with the blue smoke of problems. So that's the one with the marker on. I might have to put my stronger glasses on. I think that one is 2 up. Yeah, it looks like it is. And then these two, like I say, in any order, need to go into the A0 and A1. So it's 1, 2, 3 pins, and then the 4th one. So 1, 2, 3, 4th pin, and 5th pin. So that basically is our layout. Just checking it. 1, 2, 3, yeah, 4, 5. That is definitely 5 volts. Ground reset 5 volts, and we've definitely got the black into the ground. It helps if you do, and we can now plug it into the computer. And what will happen is that will log into the computer. Because it's already seen it, it doesn't need to do an update. What we've got now is, if we actually go back, let's have a quick look at it. I don't know why it's decided to add a bell sound to every thing, but that's possibly something to do with the output from the the other one that's programmed. So that light is flashing now. That's because when they come, they literally have a little program on them called flash, so that you know that you're plugged in, you've got power, and that LED on the board is pin 13, and you can literally flash it. And you can write your own software to make that go faster and faster and slower. You can make it go softer, I suppose, if you wanted. Faster and slower. And it's like every other pin on here, you can access it through the software. It's literally the way that microcontrollers work. Now then, we go back to this. Yeah, it's interesting. I'll put that bleep in. So what I'm going to do next now is I'm going to download the software. I've already got that, but you would now download the software. There are loads of tutorials on how to download it, and I'll put a link to one in the actual base, so that you can, if you do need to learn, go through download the software. Then we're going to then go on to this screen here, where we actually go through the process of actually doing the programming. Right, so we've got our system, or got our thing plugged into the micro. It's then plugged into the computer. I've stuck it in a bit of blue tack so that it doesn't move around, so that I can move it. There's nothing happening yet because there's actually no program in there. The program is just the absolute basic thing that comes with it that flashes the LED. So we're going to need to download the Arduino IDE. It's free on the site. All you need to do is download it. When you've got it, make sure, we'll actually go into it, load it up. You'll get yourself this screen. I'm getting some numbers because it's actually putting the keyboard through when I'm changing the scenes. So it will just say void setup, void loop. Those are like your basic standards. I don't know why that's interfering. Is there any issues? Right, so it's basically, you've got void setup, void loop. Those are like the minimum things you need into the program. The void setup, it runs once, as it says. That goes through that bit there. And the way that it works is that's the actual name. And then the bit between those curly brackets is what it runs. And same again with the loop. It's the bit between the curly brackets that it runs. So that basically, and it will keep running that and running that and running that. Now you can jump out and jump into other things, but they will always be inside that loop, nested into another loop. So basically, once you've got your system loaded like that, we've got the system down there running, and we'll go back, and as I say, it's putting in the numbers for me again, but we'll get rid of that. So first thing we need to do now is we need to go in and we need to start telling the system where and what we're going to put things. Where and how we're going to put things, I think, is a simple answer. Now, the way that these systems work is basically what you've got is there's memory, there's different types of memory. You don't need to know any about that yet, but it has like little pigeonholes that it uses to put things in. And each of those pigeonholes have got names, just like if you were sending letters to houses or you were keeping things in places, it likes a label on the box so that it knows where to find that, because you just say, I want what's in box 47 or box 53. You don't use numbers, but you use names. So the first thing we're going to do is go in and actually start putting, telling it where we're going to put things. Now then, we're going to start with the letters out. Now you notice how it's gone green. That tells me it's understood what I'm saying. Int means I'm telling it that I want to store integers. That means numbers that are between minus 32,000 and plus 32,000, which doesn't seem a lot, but it is in real terms, particularly when you've only got 12 buttons, or in the maximum that the system can realize is 1,000 variations. So 32,000 is a lot. It didn't waste in space. It's just very easy to store up to 32,000 in one byte. So we're going to then give that a name. We're basically going to call that, and I start with my. And what it does is good programming. Later on, when you're using all sorts of variables and you get massive programs, if all your variables have got my in front of them, you know that that's one you've set up and it's not a system variable. So you can always tell the difference because it says my, and it means you've got a bit of typing, but it makes sense. So I'm going to create a little pigeonhole that's called my left right. Now, to tell it that line's finished, so it knows where the end is, we put a semicolon. That tells the system that line is now complete, and I want you to create me a little box for numbers, integers, whole numbers, and I want you to call that box left, right. I want to create another one, and we'll call it my. Oops, if I can type my up. Down, and tell it that line's done. So what we've done there now is we've created two little places we can put two numbers, and we can ask it for what's in that box at any one time. We're going to create two more. We're going to say integer, int, my last up, down. If I could type, that would be nice. Last up. We'll see as we get. We'll go again. Last up, down. Finish the line, and one called int my button, because not only have we got the left, right, up, down, we've also got the button in the middle of the thing. So if I press that, it's actually a button underneath there, so that we've got left, right, up, down, and the button. So we've now defined those inside the system, and it knows where we want to put them. So one of the things that we can do is, having done all that, and what we'll do while we're at it, no, we don't need to. It'll be fine. So I was going to say, well, you can tell it what the number is that's in there, but we don't need to. Now, one of the big problems with code is understanding what's going on. So one of the things I learned a long time ago is you need eyes and ears inside your software. And one of the things you can do is, if you put in the command big S serial, no, let's try again. I spoon rise so badly when I'm typing. I think it's partly to do with being dyslexic. Serial begin 9600. Now, that is a big command on its own. What I have actually told the computer I wanted it to do there is, I've told it that I wanted to set up a serial port on the USB that runs at 9600 baud, which means it's doing 1000 characters a second, so that I can send me information back. Now then, when I've done that, I can actually then send something back. If I say serial print, and I'm going to put ln at the end of it, and I'm going to spell it right, print ln, you know, see how it's gone brown? That means it understands what it's doing. I'm going to put a brackets and a speech mark, which tells it I want to say something, and I'm going to say, basically, so I'm just watching the cat a little bit close to the heater. You be careful. Sorry, that's taking my mind totally off it. Hi there, the system is setting up. Close the brackets and put the semicolon at the end. Now then, that is not a lot of program, but it's very much what we call a whole hello world program. So if I now tell it that I want to, using this little arrow up here, program that, if I press that and make it go yellow, what that will do is, down here you'll see compiling the sketch, that little bar across there goes across, it's now uploading that sketch, as they call it, to the actual brain. Just waiting for it to finish uploading. Don't know why it's taking so long. Why would it take so long? Why are you not a happy budgie? I will press the reset on it just so that right, okay. Error. So it does sometimes have problems. So we're definitely an Arduino Micro. This port for some reason has changed. That's one of the problems. No, the port's gone back to 8. So it wasn't it for. I've never worked with this micro board before. It does seem to jump ports. So we'll run it again. There we go, uploading. And it says done uploading. So you're not seeing anything at this stage, but that software is now inside that chip. The little chip that's on the front of that board has now got that little bit of program that I've written, and it's actually inside there. So if we come back, one of the things we can do now is I can actually open up a little box here by, say, serial monitor, and basically move that over to this half of the screen, so that what we've got on this half of the screen, we've got the program, and on this half of the screen we're actually monitoring COM8, which, if you remember from your tools, COM8 is where the actual chip is. And if I press the reset button on here, it'll do a blippy blippy blip. Right, so I've had to do a little jump. I was hitting issues. Brand new microcontroller, never seen this thing before. it just wasn't doing what I expected it to do, and wasn't doing the serial print. So if we go back to the screen now, what I've had to do is I've had to add in, between the serial begin and the actual first serial print, I've had to put a 5-second delay. It probably could be less, but it's 5 seconds works, and I'll use that for now. And what that does mean is that if I now program that, so you can see the little bar across, it's now doing the bling bling, in it goes. And I now bring up the serial monitor, which for some reason jumps up or comes off the screen. It now is working, but it needs that 5-second delay before and it may be, there is a very complex command you can put in that actually won't let it go further until the serial port's set up, but I don't want to bother you with that. Let's just have 5 seconds delay, big deal. You can get into the deeper programming stuff later. So we've now got a situation where we have created our basic setup. The one thing we're going to need to do is we're going to need to do what's called a pin mode. And it always starts with a lowercase pin mode, and we're going to tell it pin 12 is an input with pull up. So what that means is that pin 12, if you remember, we connected this orange wire and the switch to that pin 12. Just over here again, and it's F3 now. I've changed it off the numbers because I was having problems with the numbers appearing on the screen. So I'm going onto in the break that you're unaware of, I jumped in and reprogrammed it all to function keys for changing the screens, and now I'm forgetting that I'm doing that. So if we have a look at the Arduino again, like I said, that orange wire goes to pin 12. So, oh, that's interesting. F2 must mean, we now need a keyboard. We now need a controller for the OBS controller with other keys on to be able to do these things. And that is, I need a much bigger keyboard. So, but what that means is, I've just told it that we're on pin 12 is going to be an input, and the pull-up means that it actually will hold the, using a resistor, it'll actually always be 5 volts. So it'll always be 1, and when you press the button, it will become 0. And it sort of seems counterintuitive, but it means that you get a lot less false signaling, and you get a lot less debouncing problems. So the first thing we're going to do now is we're going to go into this loop area, this is the bit that goes round and round and round. And what we're going to do is we're going to look at the actual ports that we're analysing, and we're going to stick a value into the actual system. So what we're going to do is we're going to start out by we're going to ask it to do an analog. I wish I could type. Analog read. Double L. This is you've got to be absolutely letter perfect. They don't. Some of the better systems will help you out, but this is a very basic system. It won't. So I'm going to say we're going to analog read, and we know that one of the pins was a 0 for the analog, where we're actually adjusting the joystick, and what I want to do is, so I've got the analog read of A, and I want to tell it, because this is backwards, you've got to say, I want to put my up, down equals the analog read. So what I'm telling it to do there, and I'm telling it to look at the pin, tell me what the value is, and put it into my pin up, down. Yeah, there are shorter ways to do it, but then this is a nice way to learn it. So then I'm going to say I want to do a serial print. I'm going to say it's not my favourite keyboard either. It's a very clunky keyboard. Serial print. I'm going to start out by saying this is my up, down, couple of spaces, and close that out, give it a, tell it to finish the line, and then I'm going to say serial print, and I'm going to tell it to actually print my up, down, or down, and tell it it's going to be a decimal. I'm going to add two little letters there that'll tell it to put a line end. Now this is going back to the very first ever teletype systems, where the actual teletype was going and to know that it was the operator, when she was rack the typewriter back, that was known as new line means it goes up, and end of line means it racks back, and it's still the way we do things in the sort of very lumpy end of programming. So if I now tell it that I want to program that, clock tower again, so now that's now loaded that program. So we should get it say this is system, and then it's telling us that this is it's the actual value of my up down is 567. So if I go over to the actual thing, if I change that now, and I'll cut back, and if you notice, it isn't my up down. My up down happens to be my left right. Up down's not doing anything. I go down, up down's not doing anything. Left right is going from 0 to 1023. But that means that as I move that joystick down, I can control that very well, really. It's a fairly little joystick, but you can control it to a certain extent. And all I'm doing is I'm literally just moving that joystick gently about. So if we now go, if we can, so that will now run and run and run. So what I will do is I will go in and alter A0 to A1, and that will be up and down. If I now take the whole of this and copy it, because we're always lazy as programmers, I'm now copying exactly the same set of commands, but I'm going to alter it from up down to, as we called it, right up the top, left right. So I'm going to cut and paste left right, because we're lazy, we're like mathematicians. We're going to make that left right. I'm going to change that to a 0. I'm going to change that to left right, and I'm going to change that to left right. Now the one thing I'm going to do is I'm going to cheat. I'm going to put a couple of spaces in there, and I'm going to take away that ln. So that now will present that as one long line. So when that's come back up, we now have a massive splooge of, so if I get hold, if I go over to the thing, if I go left, right, I'm going to go left, right, up, down, left, right, up, down. So you can actually see it happen. So left, right, up, down. So left, right is correct, and up, down is actually backwards. But at the moment we're not going to use up, down, we're going to come back to up, down as a command. So left right goes from 0 to 1023, and that is now running inside the chip constantly. So the other thing we can do is right at the beginning of this command, what we'll do is we'll add in the other read, which is a digital read of 12, if you remember, pin 12 is where the orange wire went. Yeah, and I'm doing these backwards because it does. To be honest, I'm using other languages where it actually works this way around. So, and as soon as I've done it, I'm thinking, oh, I need to go on it, and so I'm going to put my button equals digital read 12, and if I spell my button right, it'll come. But actually, we'll leave it in and we'll just show what happens. If I now say I want to program that, it's going to turn around to me and nicely highlight it with a pink line and say, I don't know what a mudge button is. But it understands what my button is. So we've only read it at this stage. We now need to go in and we're going to copy and paste this print command, and then we're going to copy and paste the thing, and we're going to set that there, put that there, put that there, and we'll put a couple of spaces in there, and then we'll run this. So now what we've got is we've got three numbers where we're actually looking all the time. And if I go across, let's have a look. I'm going to go press, left, right, up, down. Press, left, right, up, down. So if I go back and I go press, you see the button go to 0. You'll see if I go left, right, the number over the end, and up, down, the number in the middle ends. And that will sit and do that all day, and it won't do anything more. What I might do is I might just trim some of this, some of the words out, because it's getting a bit long. Same with this one. Nothing worse than trying to do stuff while people are watching. And I know you're not watching me right now, but you will be. Right, and if I now reprogram that, that will become a much shorter thing where it just says what the three variables are. So what we're doing is we're going through, we're putting the three variables, and we're doing it in different ways. We're going and we're doing a digital read, which is 1 or 0, and then we're doing an analog read, which is 0 to 1024. Now then, in reality, if we did an analog read on the button, it would go 0 to 1024. There wouldn't be any stage in the middle because it can only be on or off. And the same with the others. So what we've got now is we've got the ability to detect where that joystick is and where what the condition of the button is at any one stage. So now we need to convert those inputs into key presses, because if we look at Adobe, K is stop, J is shuttle backwards, and L is shuttle forwards. So all we need to do is basically translate these numbers into letters. With the analog, we're going to do it a little bit more. But what we'll do with the button is very simple. We're going to say if now then that shriek, no, not the shriek, that shriek means not equal to. So if not my button, which is a little bit, we're back to Boolean maths in a way. What I'm saying is, if not button, now we know that what happens is when the button is pressed, it goes to 0, not 1. So we're not looking for is the button equal to 1, we're looking for is the button equal to 0. So basically we're saying if not button, it's a very simpler way of saying if it's not 1. It's back to computer logics. It's just a very fast way of doing it. So if I say if not 1, if my button is not, and then we need the curly brackets again, because just as we've done in the outer loops, we're now doing a little inner loop inside that if, and if I actually ask it to show them, you can see how that it lines them all up as it understands them. So what I'm going to say is, in there is if my button serial print, and if I got it somewhere right, it would work. Serial print. You have to put up with me crap typing. It's I'm blaming the keyboard. You get so used to a keyboard, and this is a very old keyboard, and it's really deep press keys, and I've just got, you just get so you don't think so. We're going to say button is pressed. Oh, and I'm going to try and type that all again. So, button is pressed. I'm sorry I'm to put up with all this, but I know what I might do is put a couple of spaces at the end. Now, the problem is, as you've seen, this is running round and running round and running round. If I just put this command in, and effectively I'm going to do what's called comment out these, which by putting 2 slashes in front, we now don't have those in the thing. When I run this, what's going to happen is it's now just going to say my up and the number of my down. Yeah. So you can now see that they've got the numbers there. And if I hold the button down, all of a sudden it's going to say button is pressed. Button is pressed. But just as all those are going so fast, you can see how many hundreds of times it thinks that button's pressed. And the problem is, if we were sending a K every time, the computer's going to go, it's too much information too quickly. So one of the first things we can do to actually make things a little bit slower, because this is processing 32,000 instructions a second, is we'll now put a delay right at the bottom of the program of 200 milliseconds. So if I now program that, what we're going to see is that's going to slow the whole thing down, because we're only going around 10 times a second. So as you can see, the numbers are coming up a lot slower. We're literally only getting updates probably not 10 times a second, probably less than 10 times a second there, because I'm just wondering what else is slowing it down. Let's have a look. Shouldn't be, but it is slowing it down. But anyway, so we've now got things happening. And if I actually, a bit slow, if I now press the button down, that will be going K, 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 K. In reality, that's still too many. So one of the things we need to do is what's called a debounce. And we use a command called while. And what we're going to say is while not my button. So what we're saying is while ever that condition is true, in other words, while ever that button is held, we're going to literally just put 2 brackets there. And what that means is it will zing round inside those 2 brackets until the button is pressed. The problem is that because it will then lock forever. So what you need to do is copy this command and put it into between the brackets, so that all the time it's there, it's looking if the button has stopped being pressed. Because you can't just if the button stops being pressed, oops, don't get rid of that. If the button stops being pressed, that bit of software won't know unless we actually check the button. So what we're doing is we're checking the button at the beginning. If it's pressed, sending the message, and then we're going to sit here and wait until you let go of that button. So if we now program that, we'll see an interesting change. So we'll see so we see the start of the program, which is the nice thing about putting the message at the beginning. You can see where the program started. And if I now hold down that button, we get the button is pressed, but whenever I hold that button, it goes no further. Now then, in reality, for this application, it doesn't matter that it's frozen the processor, because in reality, we're only wanting so many key presses at a time. As soon as I let go of that, the whole thing carries on again. And every time I press button, it stops and stops and stops. So what we've done is we've made sure that when we press, we only get 1 K going in out, going into the system. Yeah. Now, one of the things you could do is use that as a start-stop, as opposed to a K, because one of the things the K does is really just stop. And if you actually altered what it was sending, you could do it. Now, we haven't got to the letters yet. One of the things we want to look at now is, one of the problems is that these, we're getting literally 500 odd variations, and we want to really shut that right down. So what I'm going to do is I'm going to use a thing called a map command. And what that does is it alters things. So I'm going to go onto the left and right, and before I'm going to surround it with a command that basically says, right, grab that, but before you stick it into my left right, do something else with it. And what I'm going to say is I'm going to say map it, and what I'm going to do is the map command. Now I've got to go, first, initially I'll take out the semicolon. The map command, you can tell it what you want. So I'm going to say I want you to, from 0 to 1023, which we know that's what it's giving us, and I want you to make that from 1 to 13. So what that will do now is that will take that long number and actually remap it back to between 1 and 13. So we're now only going to get 1, and you could do 1 to 3, you could do 1 to 10, you could do any number in there you want, however many steps you want in there. And again, I've just gone for 13 because it seemed sensible. I know that the Adobe has got 6 steps, where you keep pressing K and it keeps getting faster, and I'm going to look at this being the steps. I'm going to also, while I'm there, take the speed a little bit faster, because it's probably just their serial commands are sort of slowing it down. So if we now look at this again, and once again I'm going to be going over, and I'm going to be going left, right, but I'll go a bit slower this time. So now you can see that in the middle is 7, and as we alter this across, you can see the numbers go up. So we're only going up to a maximum of 13, and we're not going anything lower than 1. Yeah? 7, 1. So we've now controlled that. I'm not going to bother with the channel at this stage. We've now controlled that using the mapping capability, so that we've got literally 13 numbers. So the thing I'm going to do now is I'm going to start turning those numbers into letters. Now to do that, we have to go right back up to the top again. And one of the things we're going to do is bring in a library. Now then, the nice thing about the libraries in the Arduino is these are like ready command pools, things that do jobs, so you don't have to sit down and learn all the programming. You can do things fairly quickly, as you've seen already. Appreciate there's a bit of work there, but so far we've only really done, what, 20 commands? So we're going to add one more, and what we're going to do is we're going to use a thing called include. So I'm going to find the hash on this keyboard. Where are you? Let's assume it's there. Is that the hash? No, that's not the hash. Is that the hash? No, that's not the hash. Where's the bloody hash on this keyboard? Oh, marvellous. Ha 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 ha. No. Oh. What a pain in the hash. So, not seeing it up there. Is it there? No, that's a pound. Is it there? No, is that? No, that's $1. Oh, you do like these, you know. Ah, there we go. The hash. Good grief. It's right in front of me. Dyslexia. It's fun. Every day living with it. So include, and the actual library is called keyboard.h. And that's how you have to put the command. You basically, and you have to spell it right. And once it says, oh yes, I recognise that, it goes brown. So now what keyboard does is that automatically sets up a second serial port, not serial port, a USB port that looks like a keyboard to the Windows, and so we can now send actual commands. So that what we will do now is, if we literally move down here, we're going to do a simple one to start with. We know that we got the button going there, and like I say, in the shuttle, K is the middle. But I think I'm going to save you the thing. So save you all the thing of what I did. So button is pressed. So what we're going to do is we're now going to send the command to the system, which is keyboard.h. board dot write. So we're now telling it we're going to send. There are more complex commands, but we're going to do nothing more. And it needs to be a single quote. I'm going to put a space, single quote, close brackets, done. So now, every time I press that button, it will send a space to the PC. And that's as simple as it is. You could do it now one command at a time and work your way through and say, if it's this, there, that, if it's this, if it's that, if it's that. I'm going to make it a little bit cleverer than that. What I'm going to do now is go down to this bit where we know we're going to start out with, so we've got us left and right there, we've printed it out, and I'm going to say if, and I'm going to copy it to save me on to type it, because let's face it, I can't type for toffee. If my left right is equal to, and you've got to put equal twice when you're saying a comparison, 7, then no, I'm not going to put 7. Yeah, 7. Now this is when it's gone back to the beginning and to the middle. Now in my previous version, I actually did make this say K. Oh no, Sam. Oh, God grief, yeah. Wake up, guys. This is going to be the K, so that when you go to the middle, the K stops it. I've just added the space bar to the button to start, stop, play. Okay, guys, wake up. You know that's part of the problem. I've done this once ever before last night. So I'm going to give it the curly brackets, which automatically puts the second one in for me. And I'm going to say, so if it equals 7, it will then go keyboard right, open brackets, single quote, K. Right, so that is literally all we need to do. So what that will do is, unfortunately, what that will do is send a whole stream of Ks. Wherever that joystick's in the middle, it'll send a stream of K. So it'll be going K, 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 which again is not what we want. But it is that simple, so that if it's sound, and what if you did keep it moving, then theoretically your Ks wouldn't come out as often as you'd like them to. But we know that that's not what we want to do, because we know that every time that says 7 now, it would also say K, because what we've done is we've actually asked it, so if that is 7, send a keyboard K. What we need to do is go right back to this first variable. And one of the things I said was my last up down. And it really wants to be my last left right. Okay, so I'm going to copy that because we're lazy. And I'm going to add into this and say and my last left right not equal to 7. So in other words, if my last right, if we send a 7, it's going to also look and see if the left right was 7. So right down here, I'm going to put my left right equals, and we're going to put whatever the command is that it's at the moment in there. Right, so those two little things there are going to do a fairly interesting thing. We know that if it's 7, it's going to go K, 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 K. But it's only going to go K if that doesn't equal 7. So if first time it equals 7, it's going to go K. But then it's going to go through and actually make my last left right equal to what is 7. So next time it comes around, it's going to say, yes, it's 7, but it was 7 before. So we'll just get the 1K. Yeah? Fairly interesting. So what we've done is, and it's fairly deep programming in a way, we're doing equivalent of a debounce on the K. Just as we did a debounce here, as they call it a debounce, so that as that wasn't doing, that was going button, 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 there, button, 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 button. What we, by actually making it wait until they've let go of the button, what we've done down here is a similar thing what we've said. If it's 7, it's K, but then never said another K again, unless something changes. So in other words, whatever happens, it has to be different. Yeah? Right. So we know, and I've purposely said left, right, not 7, because that means that wherever that joystick is, that is recording whatever went through here. So we're now going to do a cut and paste again. So what we're going to do is we're going to copy that and put that down. And what we're going to say this time is if my left right is less than or equal to 6 and my left that is not equal to my left right. Right, we're getting deep now, guys. What it is, this is basically saying, right, so anything, as you know, it goes from 1 to 13. So anything below 6 will send, and I'm going to make that right, so we're going to say that, make that J. So anything below 6 will send a J. But if it was, so basically, first time it comes through, if it's a 6, it'll go J. But then it'll alter it to 6. So a second time round, it won't actually send another J, because if it says my left right is not equal to, which is 6, 6, 6, 6, but only when it goes below 6 and becomes 5, it'll then send another J. And then it'll go, hang on, it equals J now, it equals 5 now, and so all the way down to 1. So what we're going to do is we're basically, through just adding that little if statement, everything that's below 6 but has to be a different number below 6, it will send a J. Guess what we're going to do? We're going to copy and paste. And when it gets even easier, guys. So now what we're going to do now is we're going to say if it's greater than or equal to 8 and my left right isn't my left right, because it's the same logic. If it's 7, so first time it goes through it's 8, but then that becomes 8. So every time that comes through as 8, it does nothing, and we'll actually make that KL, so that every time that comes through, that's L. It only comes through as L. So now what we've got is we've got a keyboard. We've got the whole thing now sending keyboard rights based on the movement of that mouse. So if I now program that, be interested to see how this affects the OBS Studio. That's now programmed for now if you notice, not a lot happening. We've got the things moving up there, but there's actually not a lot happening. What I'm going to do is I'm actually going to go in just to prove the point, and just as we've got the bit there that says button is pressed, I'm going to copy that. I'm going to come down here to where it says K and say K is pressed. I'm going to come down here and copy that and say J is pressed, and I'm going to make it a capital, guys, and then I'm going to come down here and say LK and I'm going to say L is pressed. L is pressed. Now then, to make, and then right at the end, just so as it keeps the screen clean, I'm going to put another one in there, and I'm going to say, we're going to say nothing. But what we will do is we'll make an LN, so that's an end of line. Going back to, if anybody's a thing, then that sends your carriage back to the beginning. Now, what I'm also going to do is I'm going to comment these out, partly because we now want to see what's really happening. We don't need to see it reading those statements anymore. What we need to do is see what's really happening in the system. So if we now send the whole of that program to the machine, in we go. So now we can see we should get a little start command, and we're getting the spaces at the end. And if you notice, it said case pressed. I wonder whether I should alter these. You know, rather than it well, no, we'll go with what it is. You can see where I've got the programming wrong then. So if I press the button down, the button is pressed. And you notice no K. If I now go right, it says L is pressed, L is pressed, L is pressed, L is. And as I'm going further right, the L's are being pressed. And then I'm going to come all the way back. And we get a K. And then I'm going to go this way. And we get J, 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 J. We don't seem to get enough J's there. Okay, and we're back to the K. And back to, so now what we're doing is we're now, and unfortunately, because it is a keyboard, if we actually go and have a look at the screen over there, you can see where it's actually put all those letters. So they're actually, you know for a fact, because it's messed up as program, that they actually are coming through the system. So they are coming through. That's an interesting way to prove it. I hadn't thought about that. So we can now see that they are actually keyboard commands. If I press that, we get a K, get an L, get a K's, L's, L's, K's, K's, L's, space, 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 space. Yeah, so that proves it's working. So I'll now take this. Well, I don't need, do I need to prove it? You can actually see those are keyboard commands. If I now connect this into the system, we're having one last chime out of the clock before we're done. If I now connect that to any system, just moving that joystick about like that, gives me the letters that I'm looking for. And the press starts and stops the recording. Or the playback starts and stops the playback. So, I could prove it to you. I'd have to go and film it all again, right? I'll film. I think you could take my word for it by the fact that if we actually go into the screen here, and I press space, 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 and I go left, right, left, right, left, right, that we are getting what we're looking for. Most definitely. Here endeth the second tutorial. Or certainly the most basic replacement video controller on the planet. Plus, as you can appreciate, if you did this for DaVinci, all you need to do is change the letters that work for DaVinci and Vegas, because they tend to have keyboard shortcuts. We're now effectively using keyboard shortcuts, and it works for anything that's got keyboard shortcuts. So, interested in your feedback, guys? Thank you again, and I'll actually look at the camera instead of looking at this screen here. Ha.